Oh, look, we're the only ones here.
Go figure.
No one else has shown up yet.
You still haven't turned in. Never mind. Have you done your discussion post online?
Which one?
There's only been one.
The one about, what you want me to teach you?
Yeah.
Yes, I did that one.
Okay.
Yet another,
Hello.
Hey.
To go close the door. It's loud here.
All the waves. Hey, Bruce.
Hello,
How are you?
I'm terrific. How are you?
Good.
Thanks for joining.
Absolutely. How is Georgia today?
It's chilly.
I'm in Rhode Island right now. It's a bit chilly as well here.
What's chilly to you?
Well, I live in a very old house and we don't really use the heat for as long as we can because it's one of these catch-22s. It doesn't retain heat well because it's like very old, and so we don't use the heat, which makes it like even colder.
So bundle
yeah.
up.
Yeah, so I'm wearing a jacket inside now.
I get it.
Yeah, sometimes we listen to Kristen's Space Heater.
Yeah, I have my, if you can see my background, I have my fake electric fireplace, which is actually a
Nice.
space heater, keeping me a
Yeah.
little warmer. It's pretty
With
classy.
nice ambiance.
Exactly.
Yeah, so I'm a New Yorker and I'm freezing in Georgia all the time,
All right.
even though it really is a beautiful day out today, but I like my heat. So we've been just getting started right at 4:15 to be cognizant of everybody's time, and then we have, or you have till 6:15, and everybody's really more well versed than in Zoom than anyone wants to be. But so you're jumping into a fairly oiled machine today.
Excellent. Excellent. Yeah, I don't foresee us needing the full time today, at least on the Zoom. I'll just get we'll set up the PCR and we'll let that run. I'll go over all this once we start. It takes about 50 minutes to an hour to run. You don't need to sit by it the whole time. You can even just leave, and like if folks are at school and going to come back tomorrow, you can just leave and like get it tomorrow, or you can stick around. But I'm going to try and I push that sort of to the front end, so if folks do need to wait for it to finish, they can. But that's the thing that takes the longest. But again, we don't need to be here for the whole time of that. I don't foresee taking the full 2 hours. I hope no one's going to feel like I've shortchanged them if I let you out early.
Everyone's on mute, but I'm pretty sure I still heard him
I
cheer.
saw a crinkly no from
Yeah.
Sheena, so.
All right, well, good. Yeah, if you want to explain that, or maybe you're planning to right from the start, and then people can
Yep.
know what they're going to do, which way they're going to go.
I will.
Cool.
How big a group are we gonna have?
We have 19 people attending.
Excellent.
There are a few people that have paired up in a classroom. One classroom
There's
has
a pair.
5 attendants and one has 4.
Now you have 2, Kristen.
What?
There's your helper.
Yes.
Hi, Em.
Hi.
They're getting ready to do their STEM experiment with the babysitters, and I forgot a supply.
Where's the
Oops.
on the Shopee?
Okay,
We need
I'll get it. Just-
Kristen, it wasn't food coloring, was it?
It was, no, we had to, my mother-in-law just went to 3 different stores to get food coloring, yes, because I cleaned out the dollar store. But let me go grab Sharpies.
Yeah, so maybe we give everybody else a minute or so to get set up the rest of the way.
I'll let you kick it off when you think we're ready.
Hey, Megan, I've got a question for you.
Yes.
So I'm looking at this at today's session, and I don't see, there's no papers behind it. There's no protocol.
There should be.
Hmm. Mine goes from one blue sheet.
Oh, there are 2 blue sheets because they're both the same lab.
I
We're
got
doing
you.
part 1 today and part 2 next week.
Next week. Okay, cool.
Yes. So it should
Situation
say
solved.
food safety. Yeah, it should be the space food safety.
Got it.
Cool. Awesome.
All right, let's see, we have. Okay, there we go.
There we go. There's Laura. Hey, Felicia. Getting logged on.
Do we have our Clark County crew? Kayla, are you with your whole Wayne crew?
I wonder if her audio hasn't connected. There they are. Oh, they were there. They're
Okay.
there. They're waving.
Yay! Bye. All right. So, let's see, I don't see the Wayne County crew here yet, or Clark County, sorry. So, we, of course, always like to do as much social media as we can. So if you guys can all wave and smile, like, you know, or not wave, but at least smile, we're going to take a screenshot. And, whoops, get this out of there. All right. Yeah, come as close as you can, Wayne County crew. Oh, thanks, Sheena.
Hey, yeah, I'm still running around trying to get everything out of my car.
All right. Where is mine? Okay, 1, 2, Hold your smile. Got it. Except I look like a ding dong. But that's all right. Put a smiley face over it or something. Okay, thanks everybody.
All right, so did we get Athens? They're still working on it.
I think so. I don't see them on yet.
Hopefully they'll be on in a second.
Yeah, we need to get rolling.
Yeah, so we'll go ahead and get started. So again, Janet and Brittany are very busy today with iGEM. So they send their well wishes and hopefully they will make it past today and then they can sleep and be coherent again after Thanksgiving break. So today we have Bruce Bryan joining us from Mini PCR. He is going to lead you through part 1 of the food safety lab. And then Emily Gleason will be leading part 2 next Monday. So everybody got their supply list last Friday. And then this week I'll send it out on Friday and then again on Monday after Thanksgiving in case it gets buried. So take it away, Bruce.
All right, thanks. Hello, everyone. My name is Bruce. I'm the director of curriculum at Mini PCR, so you'll be using some of our equipment today, obviously, and you have in the past weeks too, is my understanding. My job with the company is developing some of the laboratory activities that we do, and today we're going to be doing one of those. So just quick over, it's a 2-part lab, so we'll be doing the first part today, and as I said, Emily, my colleague Emily, will be taking you through the second part of the lab. This is our food safety lab, and it's associated with our Genes in Space program, which I'm not sure if you guys have talked about at all. I'm going to intro that a little bit as well, and Emily will talk about it in a little bit more detail next week as well. So I'm going to go ahead and the line of 2020, I'm going to go ahead and share my screen. There you go. All right, is everyone seeing that full and everything? Great. Awesome. Okay, so Genes in Space is what the lab that we're going to do today is our Genes in Space themed lab, and so I just have a couple slides to give you a little bit of background on that. I don't know if you guys, oh, I have an agenda. Look at that. I forgot about that. So we're going to go over Genes in Space a little bit. I'm going to talk to you just the basics of the lab. What are we doing? We'll then set up the lab. Today's part of the lab, doesn't take that long to set up, but once the PCR starts, it takes something like 45 minutes to an hour to run. So we're just going to get it going, and then we're going to talk about some stuff while it's running. We don't, depending on how quickly things go, we don't need to wait for it to stop. The reactions we're going to start today are perfectly stable. So if we finish and there's 10 more minutes on your machine and you just want to go home and pick it up tomorrow, that's fine. We can do that. And I'll reiterate that at the time. While the PCR is going, I'm going to tell you all about PCR and make it just, so we're going to set it up. If you're not really familiar with PCR, we'll set it up before you've learned about it. And then as it's going, I'll give you all the details of what we did and why we did it. I'll preview a little bit about what's going on next, what you'll be doing next week to finish the lab. And then finally, I'll share some resources that we have. All right. So I don't know if you're aware, but last night, did anyone watch the SpaceX launch? Well, in that launch was an experiment from Mini PCR, or from Genes in Space. We like to think that's why they launched the rocket. But of course, it was just one of many things on there. So that was sort of the culmination of a lot of work and done by high school students and the Genes in Space team and collaborators. And so there's an experiment currently flying up to the International Space Station that's going to be performed by astronauts on the International Space Station using some of the same equipment that we're going to be using today. So this is the ISS. this whole structure here is about the size of a football field. So it's a pretty big structure up there. And since 2016, they have had mini PCR equipment on the ISS as part of the sort of central part of their molecular biology workflow. And we're really proud. Not only was the first ever PCR done in space done on a machine made by our company, but the experiment was designed by Anna Sofia Bogorayev, who you see here, who was at the time a 16-year-old girl from New York. So our equipment's up on the International Space Station, and we, to make use of it, we run a contest for middle through high school students to design the experiments that astronauts will actually do. And this is just sort of a fun way to think about it, right? Since the 50s, it's sort of been the space era. It's also been the DNA era, right? In 1957 was when the Sputnik launched. That's also when the idea of the central dogma from DNA to RNA to protein was first proposed. So, you know, for the past, what was that, 60 plus years, these two things have been sort of going on in parallel. And it was in 2016 with bringing the mini PCR to the space station that these paths actually intersected. And now there's a molecular biology workflow that astronauts are using regularly. And as I said, as part of that, we run this contest. And so that was I believe the 7th or 8th experiment that we've flown. And every year we have middle through high school students design experiments. And the winner's experiment gets worked up and brought up to astronauts. They do it. Our first 3 winners are all now published scientists. They've been published in scientific journals. We've had some middle school scientists publish their proposals in the Journal of Emerging Investigators. So it's just a great way to get students thinking about molecular biology in sort of maybe not the most regular way you expect to, but it's a great hook for getting kids to think about it. And really, it's a experimental design proposal where we just ask students, it's completely free. On the website, I think there's 5 questions that they answer, and they're something like 200 words each. So it's just thinking of a problem about how DNA technology could be used to address long-term space flight. From there, there's a whole sequence that goes through. We announce 5 people are chosen as finalists. Those finalists get paired with mentors who are graduate students at MIT or Harvard who work with them remotely to develop their ideas. They then present their ideas at a NASA Space Research Conference. And the winner's experiment gets developed into something that can actually fly. And up until this year, the winners have all gone to do publicity at the launch. They are part of a press conference, and they actually get to watch the rocket launch. So they were able to do the publicity this year, but travel was off the table. And then when it goes up there, there's an astronaut who will do the experiment. And so here you can see right here, this is astronaut Peggy Whitson, and here's the mini PCR machine. It's the same machine you're going to be using today that they use up there on the International Space Station. So that's Genes in Space. And as part of that, we decided to develop curriculum that could go along with it. And so the lab that we are doing today is that sort of space-themed curriculum. And what's really great about this lab is that it's going to take you through an entire molecular biology workflow from PCR, restriction digest, and gel electrophoresis. And so it's really going to expose students to a whole bunch of tools in a relatively simple scenario that they can wrap their heads around. I don't think I said this at the beginning. Please interrupt me at any point if you have a question. Just unmute yourself and shout at me. I won't be.
Or if you're more comfortable, put it in the chat and I will shout at Bruce.
There you go. Yeah, I'm not a Zoom expert. We use a different platform, so I'm not sure how to see the chat and everything at the same time. But so if something goes in the chat, please yell at me. All right. So the lab that we're going to do today, it's it's sort of a bit of a drummed up scenario, but again, to be able to give kids that full molecular biology workflow and really understand how all these different tools can work together to answer a question. If you're really interested in doing genes in space, I encourage folks to think about it, especially if you're looking for like remote activities that students can do. This is there's no lab work needed to do that experiment. It's just an experimental design contest. So I encourage people to think about that. This lab that we're doing today wouldn't be like a winning genes in space experiment, but it's something that can show you how all these tools could be used theoretically. All right, so Houston, we have a food safety problem. So the food they send up to the International Space Station, it goes through a lot of health and safety checks, as you can imagine. Because you can imagine if there was something like food poisoning on the International Space Station or on a long duration trip to Mars or something like that, it would be a serious problem. So that's what we're suggesting has happened here today, that there is some sort of food poisoning and people need to use DNA technology to analyze the food that's there to figure out where that's come from so that they can make a decision on what to do. So we're going to be looking at E. coli genes. We're going to be doing DNA analysis to do that, some PCR, and then next week you'll do the restriction digest and the gel electrophoresis. All right, so to set up, this was on your little list of things that you should have, I think. You should have 6 tubes with you. You should have the master mix, the food safety primer mix, 4 DNA samples. And then just one thing I want to make sure, there's a restriction enzyme, XMN1. You should not have that out right now. That should still be in the freezer. All these samples, everything that we mail to you is pretty thermostable. It's okay on the bench, except for restriction enzymes. Restriction enzymes are just something that you want to be really careful about and make sure that you keep on ice. So if you have the DNA ladder out or something, that's fine, but just double check right now that you don't have the restriction enzyme out and that it is in the freezer, because you do want to make sure.
Yeah, and it was in 4 PCR tubes. So we had already aliquoted the 1 microliter for each of them.
Oh, great.
So yeah, they have it in a series of 4 tubes. So it looks like there's nothing in the 4 tubes, but it's in the freezer bag. So.
Okay.
It's these tubes, right? They need to stay in the freezer?
Does it say like X somewhere on it, like XMNL or something?
Yeah, they've kind of washed off, so.
Yeah, so put those back in the freezer.
Okay, got it.
Cool. Super. Is anything else already aliquoted? Sorry, I should have checked that.
So we sent everybody a single set of each of these things. So we divided up the reagents.
Okay. But so the tubes that they're gonna do today are empty. Or they're gonna add the DNA, everything to the tubes that we're setting up today.
To the PCR tubes, yeah.
Okay, great.
Yeah.
Ooh.
Go back over each one.
Sorry. Oh, sorry. What did you say is in our PCR tubes?
So that's the XMNL restriction enzyme. So it should look like the tiniest dot of nothing.
Right.
Yeah, so that needs to go back in the freezer till next week.
Okay. So do we have separate PCR tubes to run?
You should have some empty PCR tubes that it says we're not in the freezer.
Yeah. So you had a bag of tubes and they're the smallest tubes that are in there.
Do they have strip tubes or individual tubes?
Strips.
Oh, fancy. All right.
It's just what we had. The joys of the equipment depot.
So I'm seeing some people still running around. So the other things, so PCR tubes, those tubes are like this big.
You have the other one to hold
I
up?
have this single one, but you guys should have strips. So those are the empty tubes. They're going to look just like the ones you put back in the freezer. And why isn't this-
Yeah, and then the rest of their stuff is in the 2.5 microliter
Okay.
tubes.
Like
so-
this.
Yeah.
Okay, great. So I'm-
Set of the small connected.
Megan,
Yes.
the little itty bitty ones go back in the freezer too? Okay.
That has the X on it.
No, they have like a whole bunch of different little things written on them. There's AX, BX, DX, NDX.
Okay, that's this one.
So do all
Or
the
no,
little,
no, no. If it says X, what's on the other one?
well, no, like they're both the exact same things because we have two separate bags. So do these go in the freezer?
If it says X on it, yes.
But they don't just say X. They have a whole bunch of different
I
X's.
think they already got labeled for these. Like how you're gonna have sample A, B, P, and P. I think he labeled them. It was Janet's student. Yeah.
What about the aluminum foil thingy?
Next week
This is next week?
or week after.
So this
Not
needs to
yet.
go back in the freezer too.
Yeah.
How many Eppendorfer tubes are we supposed to have?
Right now, you should have 1, 2, 3, 4, 5, 6 Eppendorf tubes.
Can we go back
the bigger
over that list, please?
Yep.
One of them we already put back in the freezer.
I got that part.
So
And then the 4
I'm
minutes.
not, these have been aliquoted, so I'm not sure exactly what your label says, but I'll go through them right now.
Okay,
One should be green, and
green,
that is your master mix.
yes.
Check. We have a green.
The next are going to be clear.
Okay.
One is the 3X food safety primer mix.
That
It
was
says
the-
primer.
That was the mini.
Primer.
I have two that say primer. I have an orange tube and a clear tube.
Me too.
I only
Might
have
have
one.
some extra primer.
One
I
says
only have one primer.
lab primer.
I have 2.
I
primers.
lied, I have 2 primers.
Oh, you probably have the primer also for the qPCR. So what
Yes.
else does it say besides primer?
It
No,
just
it's
says primer.
Are they the same thing?
One's orange and one's clear.
No, they're very different.
Lab
Shit.
Let me check Janet's notes.
One says primer and the one that's colored says
Says
Wow.
primers.
Primer.
Primer.
Mine say primer.
One's orange and one's clear.
Mine say primer.
Yeah, I have a plural one and a non-plural one.
Yeah, that's right. I have a primer and a primer.
I've got a lab primer and a primer.
I have only one primer.
Oh, isn't remote learning fun, everybody, right?
Is
Let's go through so set the primers aside for a second. Megan, you're looking that up. You're trying to look that up. Okay. So we'll go through the other 4 things that we need today. You should have 4 Eppendorf tubes that A, B, P, as in Paul, and NP.
Golden.
Okay, so once we figure out the primer, we can go from there. Give me 1 second. I can actually just, I'm guessing that the one in, folks, is the one that's orange, say, lab primer?
No, it just says primers.
Primers, the S.
Oh, okay.
Green and it does say lab primers.
So some people it says lab primers.
What color tube is it?
Green, green.
So we have a green one and an orange one. Some are green, some are
Also
orange,
clear tubes as
some are
well.
clear.
It appears that the orange one, the primers, has a larger volume.
Yeah.
Okay. That's a
Okay.
good, that might be, that
Yeah,
might be helpful.
I'm going right now into our production spreadsheets and
And I am going into the master mix spreadsheet of what got sent out. So this primer would be 50 microliters and next week would be 40.
Yeah.
So
That's about
Stan,
right.
if you feel like you can see the difference between 40 and 50 microliters.
Yeah, definitely. Well, one's, probably 10. Yeah.
Okay, so the one that is a little bit bigger says what?
It's the orange one. It says primers.
Primers with an S. Maybe that means food safety.
well, hold on 1 second.
Mine's opposite of that. My green one that says lab primer has less in it than the clear one that says primer.
Oh, fun.
Mine are identical. It's practically.
Well, my color tube has more in it. I can tell it's visually more.
So if it says lab, if it ends in an S, hold on. I believe that those are the qPCR primers, because the label that goes on those tubes says lab primers with an S, and the label that goes on the other tube says primer mix.
Okay. Yes, that
So-
is probably how he labeled it. So thank
So
you.
if it has an S on the end, that is for 2 weeks from now.
Or if it says lab primer.
If it says
It's
lab
2.
primer or has the S, we're saying it's for 2 weeks from now.
And so all else can return to the freezer.
We'll take the rest of the freezer now. Okay.
Yep.
Okay, I'm just gonna the freezer.
All
Yes,
right.
we will pause for freezer. Hold music, right?
That's right.
It's pick your own.
I could sing to everybody if you'd like, but you probably wouldn't like that.
All right, so I'm going to go back over this one more time. So we have a master mix that's green.
That's
We've
right.
got the 4 tubes, the test A, B, control P, and the MP.
Yep.
And then we have the primer, and that's all.
Yep. Those are the tubes we need today.
Perfect.
Beautiful.
Now with the tips, are we using the aerosol resistant today, or does it matter?
Those don't fit the P20 pipette.
They
So
won't?
just use the other ones. They were autoclaved.
The ones you said? Okay.
Hmm.
Okay, does it look like we have everyone back? Good, not quite.
Good to go.
All right, I'm going to start in just on some of the background of the lab. And if people are still finishing up, it's okay. That's not, this is not the most critical of information, but it's just the context for what we're doing today. One fun thing about the ISS that you may not be aware of is that it's actually a pretty multicultural food experience. It is at the International Space Station, and one thing astronauts have like they have a weekly dinner night where they share meals from around the world, and one thing that they also like apparently is these resupplies, because they actually get fresh food for the first time in a long time. This time they got fresh ice cream and berries, which is apparently everyone was very excited about. You know, the idea that we're going to be talking about space burgers and space sushi, that is real things that people have up there. This is the Russians enjoying some space borscht from a tube. But yeah, so they eat all sorts of different kinds of food. And you can imagine from just news on the ground that, well, food safety is a major public health concern. You've heard all about it, and it's something that they have to be very careful of on the International Space Station as well. So that's our context for this lab is what happens. What would you do if you had a problem like that? So we are going to be using the tools of molecular biology to look at these different strains of E. coli. So it's important to remember when we do this that, bacteria are all around us. There's, one of my favorite facts is that there's something like 10 or 100 times bacterial cells in your body than there are human cells. So basically anything you do, you're consuming tons and tons of bacteria, and most of them are just completely harmless. There are some that make you sick. And the question is then, how do you know whether you have that one strain out of the, thousands of strains that are inside of you? The traditional way is through culturing. That can be slow. The molecular methods that we're going to do today, you'll see you would be able to get this type result extremely quickly, within just a few hours. And it's all going to be based on actually this paper right here. If folks are really interested in what this lab is based on, is looking for a specific mutation in this FLIC gene, which it actually doesn't cause the pathogenic bacteria to be pathogenic, but it's associated with it. So these E. coli that are pathogenic have this mutation in, it's actually a flagellum gene, and we can use that to identify which bacteria are harmful and which ones are harmless. So we're going to do that using the mini PCR and the blue gel. And so today we're going to set up the mini PCR and do a PCR reaction. This would be the entire workflow. We're going to do some micropipetting to set it up. We're going to set up our PCR machines to actually amplify the DNA. You'll then next week come back and do a restriction digest, and you'll visualize your results on the gel at that time. So we're going to do these first two steps today. And so just to make really clear, the goal of what we're going to do here is to make about 1 billion copies of that FLIC gene. Okay, so PCR is very good at taking a complex DNA sample, finding what you're interested in, and making 1 billion copies of just that very specific gene very quickly. And so we're just going to try and key in on this one gene in sort of all the DNA that we're looking at, and find out which type of DNA comes in these different foods. or is found in these different foods. So we're going to go ahead and get started. Everyone should have a pipette. I'm not sure if you have our models or different ones. This is one of our older models.
It's one of your newer models.
Sweet. They're very nice. I have the old, they give me the junky old ones. My understanding is that we're all good at pipetting here. Yes? Do we need a pipette refresher on how to use the pipettes? Anyone? Nope. Was that a no? No? Yes?
Nope.
No. Okay.
Yeah, I don't see any nodding, so.
Okay. So there it is. You can look quick. We'll talk us through it too. Just a quick thing, a shot for one of our products. It's very inexpensive. We have these little cards. They just look like little credit cards. And there's a little protocol that comes with them for practicing pipetting. You can practice picking up and putting down liquids. And then if you're interested in loading gels, we have these little silicone gels that are good for practicing. You can't actually use them to run a gel, but for students, you just use, food coloring with this and practice the pipetting so that when they actually get to the real thing, they don't mess it up, because we know that reagents are not free in a molecular biology lab. All right, so let's do this. We're going to set up 4 reactions. A is going to be our sushi, B is for our burgers. And again, I know I'm going to go through, once we get this all set up, I'm going to go through and make sure we understand everything that we're doing, but we're just going to get it running first. A is going to be for sushi, B is for burgers, P is for pathogenic, and NP is for non-pathogenic. So first, that slide looks like it's out of order. 1 second. Oh no, I'm good, sorry. So these are the things that we're going to put in our reaction. We're going to start by putting in our template DNA. Those are the tubes A, B, P, and NP that we have labeled. We're going to put in our primers. We've talked about those at length now, so we know we have the right primers. In the reaction also goes a DNA polymerase.
Ooh, okay.
Now, DNTPs, buffer, but the nice thing is that when we say master mix, it's these last 3 ingredients all go together. So there's just 3 things to put in, but there's actually 5 sort of main ingredients in a PCR. And we'll talk about what each one of those does once we get the reaction running. So first thing, we're going to take our tubes, and I hear they may be labeled already. So you, I think, have a strip tube of, is that right?
Mm-hmm.
And you have 8 tubes there connected?
I think she cut them into 4s.
Okay. Are they, so if they're cut into, oh, it looks like an 8.
Ah.
And how are they labeled? Are they already labeled?
Nope.
No.
Okay. So we're going to go ahead and we can, why don't we break it into 4s? That's nice and easy. To break a strip tube, you just grab the 2, grab each set of 4 and just twist and pull, and it'll pop right apart.
Just like all those kids' toy things that you have
Just-
to pop out of the plastic.
Just twist it and it should pull apart. If it's too hard, we actually don't need to. I was just gonna a little easier. Are people having trouble breaking it?
Got it, Sheena? Not yet. Or cut it, scissors.
Are they empty
Yeah, there you
tubes? Are they empty tubes?
What's that?
Are they empty tubes?
Yes, it was in the bag of empty tubes.
So, good job, Sheena. I see it. All right. So once you have them split, you can label them like this. Just A, and you want to label it on the side wall of the tube. So on a tube like this, there's the side wall where it's flat, and then it sort of goes down an angle. You want to label it on that sort of flat part of the side wall. Other places it tends to rub off. So A, B, P, and NP. And once you have them labeled, we can start adding reagents. Okay, so to all 4 tubes, you're going to add these 2 reagents. Your green PCR master mix, 15 microliters of that, and green PCR master mix, and 10 microliters of the primer. And if anyone is fallen behind or confused, please shout out, because we want to make sure that we all get through this part. So when you're adding it to the tubes, it's a good practice. I like to hold up the tubes and touch my tip to the side wall, and then push down to the second stop and remove. And change your tip each time.
And just to confirm, everything that you have up on the screen right now, 1 and 2, I'm putting into
both tubes. Yep. So this part is identical for every reaction we're doing. And then the next slide, we'll put the DNA in, and that will be different for every tube.
They all get the master mix.
They all get the master mix, and they all get the primer mix.
One of our groups is a little bit behind and still setting up, so
okay,
wanted to update you.
Ooh, I'm a little short on the master mix.
How short is short?
I think maybe some's in the top. I need to spin it down. Let me see.
Yeah, spin a good human centrifuge with your flick of the wrist. You get it down pretty well. I'll just say one of the nice things about doing this lab is that it's a really robust PCR experiment. A lot of people, when they want to do a PCR, they sort of know the amount of things that they want to do, and they want to extract DNA from all different things and do PCR on it. That's great, and you can, but PCR tends to have a little bit of magic associated with it because it's a lot of moving around clear liquids into different tubes and hoping that it works in the end. That's one of the nice things about this lab is that honestly, if you put 10 microliters of master mix in there instead of 15, I will bet you that it's going to work just fine.
Yeah.
That's not true for all.
Okay, not to bring up this primer issue again,
yep.
But we did confirm that we are going with the primer, no S.
No S.
Save the S for next time.
Yeah.
Well, time after next.
I can't promise you that's right, but it's
that sounds
better.
Very reasonable and like what her student would have done. So.
All right. Wrong and strong. That's what you want to be.
So I have the master mix in each one, and now I'm adding the 10 microliters of primer.
Exactly. And to each one.
Okay.
And don't worry about mixing it yet. Wayne County, how you doing? Have you caught up a little bit? Well, we have plenty of time, so I'll give folks as much time as they need, but I just don't want to leave anyone behind.
Cool. Wayne County's getting there. Awesome.
So the primer and the PCR mix, that's the same for really any lab you will ever do. There's different PCR mixes, but there's different versions of it a little bit, but basically what's in that tube is the same for any PCR that you ever do. The primer mix is going to change by the experiment. That's going to be what gene you're looking for. And so then the last thing that we're going to add now is our DNA, and that's what's going to be different for every different tube that you do. So here, you're just going to have, you should have a large tube like this that's labeled A. You're going to put 5 microliters of that into your small tube labeled A. Then you're going to change your tip, put 5 microliters of B into B, and so on right down the line. Now, I'm going to show you one thing. Here's where we may want to start thinking about mixing it. If you're confident in your pipetting skills, one way to mix it is to put your tube down into the liquid and then pipette up and down. Before you go to that second stop, you just pipette up and down a few times. I usually don't do that. My preferred mixing method is just to close the tube and flick it with my finger and then shake it back down. Either one of those works great.
Hi, can mini PCR's master mix basically be used for any PCR experiments?
Yeah. Yep.
So can you buy that like in bulk for a classroom?
Absolutely. Yeah. With any like PCR, there's often some, just sort of troubleshooting and whatever that goes with the particular lab, depending on what you're doing. But if you're interested in doing something, yeah, you can just let me know and we can figure out what'll work best for that. But yeah, we sell it just master mix, and we have researchers that use it, as well as education.
And Laura, if you look in the folder that you have for the course, there's a PDF that says mini PCR partners with Georgia Bioed or vice versa. So basically going through us, you can get a little bit of an extra discount. So just mention us when you order.
And I'll,
Wayne County's done. Woo!
oh man, now they're ahead of me. That happened. All right. So there we go. And just, again, flick and shake down, or do the pipetting up and down. I'll put this up again, but I probably should. I'm just putting my email in the chat. It's pretty easy. Oh, except I spelled my name wrong. And if you have any questions like that, just feel free to email me directly. We actually, I mean, it's one of the fun things that it's like one of the time consuming but fun things that we do. I'm helping a teacher in Utah develop primers to identify invasive mussels in local rivers and things like that. So there's sorts of, if you have like some crazy idea that you want to talk to us about, we love doing that kind of thing. It's fun.
So is there a database where you can look this up pretty quickly?
The type of primers that you need and whatnot? There's not like one database, but you just find them in published papers.
Gotcha.
Or you develop them yourself.
Seems like an opportunity then, doesn't it?
It would be a big database. You can also develop them yourself, and there's tons of resources for doing that. We'll talk about that a little bit. All right. So if you're all loaded up, oh, I went the wrong way. I rearranged my PowerPoint at the last minute. Yeah. That got moved, so we'll just jump to here. Okay. So we're gonna set up our PCR now. So you want to have your PCR machine out and your device to program it. Is anyone using a Mac right now? We just learned today that if you're using a Mac and you've updated it to Big Sur in the last day, your mini PCR app may have broken. So our engineering team is working on that very, very hard to see if we need to fix the app or if they need to fix Macs. But just want to make sure that no one's relying on that right now.
So I'm using my phone. I have an Android.
Okay.
app. Be okay?
So there's two types of machines that you could have. If you have the Mini 16, it has a okay. That has the black. I understand some people have different ones. Is that correct, Megan?
There are 1 or 2 Mini 8s out
Okay.
there.
So if you have the Mini 16, it has a black base right here, and it has 16 wells. The Mini 8 is white and has 8. I wouldn't recommend using the Mini 8 with an Android phone, but the Mini 16 works great. And I might have to do a quick little side explanation to you to how to get in there. All right. So what we want to do, you're going to take out your machine, plug it in. I would recommend, even if you have a Mini 16, Mini 16s are able to connect via Bluetooth. I would recommend that if you have a laptop, don't try and connect via Bluetooth. It's just one more thing that, whatever. It's just easier and quicker to use the USB cord that comes with it. I have mine set up to use with Bluetooth, and it's fun. You can control your machine in the next room, but there isn't that much reason to do that. So once you do that, we're going to open up the app. And I'm going to do that and switch what I'm sharing. Okay, so, oops, where'd it go? Sorry, I lost my app. Okay. So, that's not the right thing. So do folks have this open on their computers? Great. We are going to do a new program. So to do that, we're going to click up on this blue plus sign in the top right. And I'm using my cell phone to record myself, so I can't show my app. But if you have it open, there should be a blue plus sign if you're using the app on your phone in the top right as well.
Got it.
You're going to click on that. And we are going to choose a PCR.
I'm supposed to have an app already on here on the
On where?
I had my tech guy because I was having problems getting it on here. I had to, I don't see it. It's supposed to be, can I get to it on?
Can't hear you too well, Felicia.
Okay, I just have a regular laptop. I had my tech guy to come and put the, try to put the software on for me. But I don't see it. It's supposed to be like an app showing up? Or
They put it on there, but they didn't leave it open for you.
I mean, it should, if it's just on a laptop, it should be in your like program list. If you go to the menu, it has, where's mine look like? if you go to, if it's installed in the program list, it looks like a little folder, and you click on it, and the mini PCR is an M in a blue circle is the icon for the app. So while you're looking for that, other folks can, is the protocol in the paper that they have, Megan? So you can just start entering that information in.
It's on page 11 of the food safety guide. They have the instructor guide.
Okay, great. So we're doing the new PCR protocol, and we're just going to change some of the temperatures and times here. We're going to do 30 seconds for the initial denaturation. We're going to change all the other times to 5 seconds for the denaturation, the annealing, and the extension. The final extension, we're going to have 30 seconds. And the one other thing that's really important to change is under annealing, we want to change that to 57 degrees. Oops, changed mine to 50. Come on, change it. 57 degrees. And we're going to do that for 30 cycles.
Okay, so are we doing what you have written up here or what's in the book?
Are they different? So I just realized right here, yeah. So what I put up, it should be 30 seconds. Is it different in the book? What's it say?
Initial denaturation, it says 94 degrees, and then it says 30 seconds.
Okay.
And then the denaturation, it says 94 and 5 seconds. Then annealing 57 degrees and 5 seconds, extension 72 and 5 seconds, and then final extension 72 and 30 seconds.
Yeah, that's what I have. Are you seeing my mini PCR app?
The screen a second ago was the other one.
Oh, okay. Sorry.
Yes. What is up here right now?
Oh, I'm sorry. I moved it around. I thought it was still presenting. Sorry. So I apologize. So here it should. Can you see it now?
Yeah, and this is the same as what's in the manual.
Okay.
Cool.
Once you have that, if your mini piece, oh, we haven't put our tubes in there. So we want to do that. So we have that program. We're going to put our tubes in the machine now.
And Laura pointed out that the lid might be tight, so they need to loosen.
So the first thing you want to do, just to be safe, is take this black knob on the top and just go lefty-loosey so it's nice and loose. To open it, there's 2 little nubbins sticking out on the side. That's the latch. You're going to squeeze those and then just it'll hinge up.
Do we turn on the unit?
Don't need to yet.
Okay.
Once it's open, you can just put your 4 tubes in. It doesn't really matter where you put them. I tend to put them in the middle, but it's all equal. And then once your tubes are in, you can just swing it back down, snap it shut. And then you're just going to tighten this knob until it gives a little bit of resistance. You don't need to, don't crank down on it, just until it gives a little bit of resistance on it.
And righty-tighty, because your thing is mirrored.
Oh.
So it looked like you were twisting it to the left.
I can probably stop that, right?
Yeah. Right, now I'm noticing it says mini PCR backwards on your thing.
Huh. Okay. Yeah. Sorry. So righty tighty. It looked like I did it backwards apparently. Now, if you're not using a phone, I'll come back to you on the phone in just 1 second. You can go ahead, just hit save and run. And when you do that, you're going to have 3 lights on the front of your machine that should all flash together. And that means it's all loaded up.
Do I need to turn the unit on?
You don't have to yet.
Not yet.
Once
Okay.
it's loaded, and I'm going to turn mine on.
So on means run.
Yep. And you'll see my screen here. It says now heating lid. And there's a green light flashing on mine, which means it's starting to go.
I only have 2 lights that were, you said 3. I only have the yellow and the blue before I turn it on.
That are flashing right now?
Mhm.
Yeah, don't worry about what's the blue is for Bluetooth, the yellow, it's not on. It's just when you hit the load, it'll flash 3 times and then it will stop. So if you miss that, you won't see it. That's just how and you'll know it's going though. You'll want to see here on your program, it'll say what it's doing. It should start by heating the lid. And I forgot to name my protocol, but you can go down and lower down. You can see make sure that it's saying that 30 seconds, 5 seconds, 57 degrees. That's in that column on the left. Now on your phone, you want to turn your machine on first.
Okay.
And I got to remember this. In the top right, there's like 3 icons. I think you want to hit the one that looks like an M. And that's going to let you connect via Bluetooth.
Okay, so I don't hit save and run.
Not yet. You need to connect to the machine first.
Okay.
So you're going to hit that M in the top right.
Yep.
And then it should show you your machine. It should say that.
I think I've already connected though. I already.
Okay.
You have one listed.
So this is how you know, on your machine, is it a flashing blue light or is it a solid blue light?
It's a solid blue.
Oh, you're good to go. Hit save and run.
Yeah, with the flashing other lights on it. Yeah, I connected earlier.
All right, great. So yours is on and just hit save and run.
All right, cool.
All right, Stan's is going.
So mine says no power.
Okay, so now turn it on. The
Oh, perfect.
The Mini 8s, they have an auto start function. In the Mini 16s, you can set it to have that. So when you turn it on, it automatically starts the last program that was loaded. That can be a nice feature if you, for whatever reason, don't want your students programming the machine. You just want them using it. I think programming the machine and using the software is one of like the key features of this, but some people just want to say like, I want to program them all and just have them turn it on and go. So if you want to do that, you can. But that means that it's good, just like best practices, to load it on first so it doesn't start the last program that was loaded when you turn it on. That can be important in some other things. Okay, so is anyone in need of some troubleshooting on that real quick before we move on and talk about what's actually going on?
Well, I was still having a problem. It said it was installed.
Have you gotten the program on?
I was trying to search on the PC for the, it says program files, new PCR. I was trying to.
So is the Is the software on your machine now?
I still don't see anything. They said, you said it had, see, I'm here in my Windows, the 10 thing here. Trying to look.
You're on your Windows thing. So if you type in the search bar, if you type mini PCR down there, does
Oh,
it
right
come up?
down here. Okay, hold on.
Yeah, try that.
Right here.
Where's everybody else? Laura's good. I see one thumb up. Rebecca, y'all are good. Felicia's working on it. Wayne County. Can't see y'all. I see Athens is working. Tiara, how you doing? Good? Cool.
I see it says mini PCR app.
You found it?
Does that say open?
Yeah, open it.
That's saying the setup wizard.
Oh, it hasn't been installed yet. So go ahead and
You don't think
install
it's been
it.
installed? Okay.
That's the setup wizard.
Yeah, it said it had one already installed, but I can't find it. And let me see if I can find it. This is where I had.
Okay, so I'm gonna
So
I'm
Melinda
gonna-
said they have 8 copies so far, but don't have a pretty nucleotide color on their program.
okay, yeah, I get the advanced versions of the program.
Of course you do.
So this is the newest version that will be released soon. So our DNA got colorful is one of the
So it'll be the next release maybe?
next release. Yeah, we did some redesigns. There's actually a special one that goes to space because they need high contrast, because one thing that happens in space is that you get bad vision. And so there's an extra high contrast version. We decided not to go with that, but we added a colorful DNA. But the animations should be showing the same thing. Okay, I'm gonna move on and start explaining some stuff, and then I'll come back and just check in on programming that last machine. Sound good?
Okay.
Okay. So folks said they already have, let me remind myself what I'm doing here. Okay, so PCR. I have one slide out of order. And let me share, change what I'm sharing. Oh, I am sharing that. Okay. Okay. So the idea here of what PCR does is that it finds very specific sequences of DNA and it makes billions of copies of them in about an hour. It's an incredibly powerful technology. It really revolutionized molecular biology when it was introduced in the 1980s. And there really is, molecular biology before PCR and molecular biology after PCR. I cannot imagine a published molecular biology paper today that they didn't use PCR somewhere in it. It's just the central workhorse of a molecular biology lab and has been for decades. The basic idea that I want you to think of is, I like this analogy. If you were to take the human genome and write it out 500 nucleotides per page, so this represents a piece of paper here with 500 nucleotides on it, A's, T's, C's, and G's. If you were to do that for the entire human genome, you would need a stack of paper higher than the tallest building in the United States. So that's taller than this, it's a little bit more than a third of a mile high, taller than the spire on One World Trade Center in New York. And again, that's reams of paper just stacked on top of each other. For this and most PCR experiments, you're interested in like one page of that. So you can imagine how hard it is to find that one page and study it. So the power of PCR is that it's very good at finding the page you're interested in and then putting it through a little molecular photocopier. And the trick that it does is it finds that first page and it puts it through so that you get 2 pages. It takes, instead of just copying that original page now though, it takes both pages and passes them through again. So you go 2 to 4, 4 to 8, 8 to 16. And if you know how exponential growth works, you get a lot of paper. If you do that 30 times, you get 1 billion pieces of paper. So just to complete our analogy there, a stack of 1 billion pieces of paper is about 63 miles high. So we went from something about 1/3 of a mile high that only 1 piece of paper was what we're interested in. Now we have a stack of paper 63 miles high and every single page is the one that we want. Okay, so that's the power of what we're doing here, but molecularly. Finding and replicating a very specific DNA target. The way this works in the machine, we set 3 temperatures. It heats up to 94 degrees. At 94 degrees, that DNA denatures or melts, sometimes you call it. So that the two strands, the hydrogen bonds that hold it together, the energy in the thermal energy in the tube is greater than the hydrogen bonds that hold the strands together, and those 2 strands separate. We then have our primers, and our primers are those very specific sequences that match the beginning and the end of the DNA that we're interested in. And so we cool it down to, in this lab, it's 57 degrees. And those primers will come in and bind to the beginning and the end of the sequence that we're interested in. And that 57 degrees, that's something that changes in your primers change in every PCR experiment, and that temperature will change. And that's dependent on the primers. It's dependent on how long the primers are and their AT and GC contents. And then the last thing is we heat it back up to 72 degrees Celsius. And 72 degrees Celsius is where our polymerase, our Taq polymerase, is active. And so at 72 degrees, that Taq polymerase will hop on the DNA, and it will take the dNTPs, which is the other thing that we put in those tubes. Those are the unincorporated nucleotides, and it will build the new strands of DNA. And then you just do that over again, and then you do it again, and then you do it again. And each time you're doubling. And just a quick note on these temperatures, I'm really bad in Celsius, but 94, right, that's almost boiling. 50 to 60 degrees, that's too hot for bath water. So it's a little too hot for bath water. It's not going to burn you, but if you're in there long, you're going to get a little scalded. 72, I think, is about like a cup of coffee. So these are all very hot temperatures.
You have a question?
Absolutely.
Okay, so we've gone through the system and set it up, and I've put everything into the program to run it. And when I tell it to upload it, and it says select PCR, it doesn't give me anything to select.
Do you have a mini 8 or a mini 16? Does it have the white or the black part on the top there?
White.
White, okay.
It holds 16 of them.
It'll hold 16?
Yeah.
Okay. Okay, so that's weird. So why don't you just try turning on and off the machine and unplugging it and plugging it back in. What's that?
Already did that.
Did you unplug it from the computer?
Yes.
Okay, then I would suggest restarting the software one time. Your program will be saved in it.
Okay.
And I'm sorry, I don't know names, but the other person that was having trouble now that we're paused. Megan, do you know who that was?
I didn't see who else was having trouble, and now I've changed the view to where I can't see it.
Forbes, F Forbes.
Oh, Felicia?
Yeah, I'm trying to get on my, but you said if we use, the iPhone, you said something may happen.
No, so iPhone, do you have Mini 8 or Mini 16 is the question. So if you look at this part of the machine, is this white or is it black? On the top.
The top part?
So if you unscrew the top.
If you just hold it up to your screen, I can see it actually. Yeah, that'll work on your iPhone. Great. Yep.
Okay.
So I would just unplug for you. I would unplug the USB cord, and I would download the app on the iPhone. It's fun to use your phone. And who are the folks that were having trouble? Levi Carr, right?
Yeah.
Hi, Levi. How did that do anything for you?
Not at all. I'm sorry. Just want to be rebooting, I guess. If we're rebooting, like you said, we're rebooting.
Okay.
Better to see if it's a program issue.
Yeah,
Because when we were in there, we were trying to pull up the mini PCR, like the program's supposed to appear so we can select it. And so when we opened up that small box, it wouldn't allow us to select it. So we're gonna reboot, like you said, and hope.
Yeah. And I would just turn the machine off and unplug it one time too.
Okay.
Give everybody a good power cycle.
Yeah.
So I've got a technical question.
Absolutely.
So how are you cooling this down so quickly? Is it fans?
It's just fans.
And okay, and because the tubes are so small, they quickly cool.
It's in an aluminum block.
Yeah.
Yep, it's just in an aluminum block with fans, and it cools because they're so small. It
Gotcha.
just cools really quickly.
Yeah, that's really fast.
Yep. That's one of the reasons our PCR cycle times can go so quickly, just because it's small, and so we can cool it down fast.
Yeah, my regular thermal cycler takes a lot longer.
I just saw someone ask, when you're done, do we want these in the fridge or freezer? Someone has a lot of noise going on. I'm not sure that is. So yes, it's good to put in the fridge or the freezer. Either one is fine. They'll actually be fine at room temperature as well. But for best practices, throw them in the fridge or the freezer, and they'll be good.
I have a question about the cycle times that we've used. So I've run a mini PCR cycle before, and I was surprised that you have 5-second
It's incredibly
intervals.
short. Yep.
Can you do that with any mini PCR protocol, or is that just for this one?
So that's one of the things. This one's optimized to have a short protocol for sure. Traditional PCR programs build in longer cycle times than is actually really necessary. It's just something people put in. So this one really optimized it to be as short as possible. 5 seconds it's ridiculously short. It works well. We usually do times closer to like 15 seconds. Yep. Do we get that? Did we get it?
I saw
connected?
some clapping. Not yet. No.
Okay. I have seen that happen like once or twice a very long time ago, and I haven't run into that problem.
Maybe if one of y'all can download it on your phone.
Yeah, if you have the Mini 6, so to that group there, If you have the Mini 16, it does go down on your, you can download the app on your phone very easily. And you can try that. But otherwise,
Mr. Brian,
yeah.
we may have downloaded the wrong one. So we had to whenever we went to re-download it, we think we got it correct now. We're trying to
Okay.
get-
You got it.
Yeah, you have to make sure that if you have the PCR 16, that you download the 16
Yes.
software. So that's kind of the key to match those up.
Yeah.
No, I mean, seriously. No, seriously, because.
All right. So
Right.
troubleshooting.
Excellent. You got the legacy software on there. Excellent. Great. Okay. So I'm going to move on. Thanks for everyone for being patient here as we troubleshoot some things. So yeah, so we go from a single molecule. The idea is we denature the DNA through this repeated cycling. You're going to get lots and lots and lots of DNA very quickly. You get the idea. We already talked about what you put in the tube, but if you want to just, if you have it running, and I will go ahead and share my screen again. Oh, except I lost it. Oh, screen sharing. Here we go. So one of the nice things about the app, if you're seeing my app now, I think so, is that it's going to show you what's actually happening in that tube in real time. So I sort of talked you through it, but this is what's really happening at the molecular level. It's graphing your temperature over time in that graph, so you can know exactly what's happening. And then people already commented about the animation there. So right now mine is annealing. Those primers are going in and binding. And then it's showing that graph of exponential growth. And so mine is at theoretically 32,000 copies for every one I started with. And so if you've ever taught PCR before or anything like that, going from just telling students what's happening to them being able to see what's happening in the machine in the time that it's happening it can be really powerful. Just that reinforcement. Annealing, and now it's going back up to extension, and you can see it's creating the copies. The other things you can just see on here, it's going to tell you on the top running. Mine has been going for, it has about 21 minutes left until it's done. It's been going for 22 minutes. And then it just shows you the times down here. Okay. Where do you go? Okay. Oh, I am on the wrong slides. Hold on. Sorry. That's my wrong slides. Okay, I closed it. All right, apparently I closed my presentation. Oh, here it is. Got it. Okay, sorry about that. New share. Okay. All right. So we talked about the stuff that we put in there. We put the DNA. Those primers are that key things which finds that gene that we're interested in. The polymerase is what actually makes the copies of the DNA. The DNTPs are the building blocks, and that buffer is just the liquid that it's in. It maintains the pH. It provides some magnesium chloride, which is a necessary cofactor, but we don't need to worry about that. And really, you could, it's cell, if you're teaching DNA replication, that's what's happening here. So it's got all the core processes of DNA replication, but we just do it in a tube. Just quick side note, these are the mini PCRs. The first ever thermal cyclers were actually just water baths. If you've done a PCR since 1986, you did it in a machine that looked, oh, they start looking more and more fancy than this, but this is the basic idea. And so it's a big old box that holds a lot of tubes. The breakthrough in the mini PCR is just simplifying things. As we said, cooling things with fans, heating things with simple technology, taking the computer out of the machine and just using it on your laptop or your phone. It's really not a difficult process, but making them small has really dramatically increased the amount of access that people can have to them. And then also with the apps, the idea of actually showing you what's going on there in the tube can be really powerful to students. And it can go places that you never expected. So this is it in space. One place where these machines have become quite popular, sort of unexpectedly for us, is with field biologists. So this is Dr. Elaine Guevara. She studies lemurs in Madagascar at field stations where there's no electricity. So she uses these power banks, just sort of like spare laptop batteries, and she can do her PCRs in the field there. Another great example is Dr. Ian Goodfellow during the Ebola epidemic in, I think it was 2015, brought a whole bunch of very expensive molecular biology equipment to West Africa, and in the field conditions there, they failed. And so many PCRs were able to get his sequencing operation up and running again. But we're doing this lab, so let's talk about the rest of the lab and why we're doing it. So we keyed in, and what the mini PCRs are doing right now is making the billion copies of that gene that we're interested in. We then want to know which type of that gene. Is it the one that comes from the pathogenic bacteria or the one that comes from the non-pathogenic bacteria? And we're going to use a restriction digest to do that. We're not going to go into restriction digest in detail today. The basic idea is that it cuts DNA at a very specific sequence. In this case, it's going to be the XMN1 restriction site. The key thing to know here is there's a difference in the DNA between the two genes from the pathogenic and non-pathogenic. And we can use a restriction enzyme to do that. And then we'll use the gel electrophoresis to actually visualize our results. And that's all stuff that you'll do next week with my colleague, Emily Gleason. Electrophoresis is just a method of separating DNA by size. So this is a electrophoresis gel. If you zoom in on it, you pull the DNA through this complex web, and depending on how big the DNA is, it will separate. And I'm not, just based on time, I'm not going to go through all that today. You'll learn all about it next week. I did want to, though, talk about the resources that we have available for you. So as we said, GeneSpace is a contest, and we encourage you to check it out for your students. It's an excellent sort of hook to get kids inspired in space biology. As part of that, we provide a number of resources. So one thing that's great is we work with a science YouTuber, Dr. Alex Danis, and she's made these videos where she's gone and interviewed NASA scientists about experiments that are being done on the International Space Station. So I'm just gonna, oh, it says it cannot play media, okay. Anyways, she goes, and these are 5-minute videos where she sits down with different NASA scientists about actual DNA research that's being done on the International Space Station. So we've built a lesson plan around this, and this is just free to download off the Genes in Space webpage, where the idea is different groups could watch what different scientists are doing, they can report back on them, and then they can use these as a starting point for their own ideas in sort of designing a question and an experiment that they may want to do. We also have videos explaining this entire lab. We have videos on YouTube just explaining how PCR works, and some really solid worksheets that are free to download off our website that go along with that. I'll show you this one for just a second.
I don't think it's sharing your
Not
sound.
sharing the audio.
Yeah.
I'm not going to troubleshoot that right now. You'll get the idea. It'll take you through the entire video. It's showing you how to do it, explaining every step. And again, those are all for free download on the Genes in Space webpage. There's a whole thing about for teacher resources.
The classroom resources page.
Yep.
I just put it in the chat.
Excellent. Just one other thing that we have. I know that, well, we're doing this through you folks. We also have a loaner program where folks can get equipment for 2 weeks and do this lab with at least 2 classes. And it's, we say it's free. We ask for $100 for shipping, but we've waived that in a number of cases. So if you're interested in that, or if you know teachers that may be interested in that, you can request a kit. We only do like 25 to 30 loans a year, so it's a bit of a competitive program, but it's actually a lot easier to get than you may think, based on the fact that we're mailing you like a $5,000 worth of equipment for 2 weeks with labs and everything. I think something like 1 in 5 people who applied last year got it. So it is quite available. You get all the equipment that you're going to be playing with today and next week, and the lab that we're doing today with all the videos and all the support that you would need to make it successful. And if you're interested, this is a QR code that you can take if you're interested, or if you want to share it with somebody that may be. Let's throw out there, we have a bunch of other labs. I'm not going to go into them today, but things from like taking your own DNA to just running gels. If this particular lab has a lot of steps to it, though it is really robust and it works very well. But depending on your the topics that you may be interested in, or if you want a simpler thing to do, you should check out our catalog. We have a bunch of stuff. And if that interests you, again, my email's in the chat. You can feel free to email me directly. I have you can test GMO foods to see if they have GMO, if they are GMOs. All sorts of different stuff. I won't go into them all now. That's the majority of what I wanted to present today. So I'm going to stop presenting and just, if I can remember how to do that. Come on, screen. It's supposed to pop up, right?
I can stop your sharing.
Yeah, it won't. Thank
There
you.
you go.
It wouldn't come up for me. Anyways, so I know some folks were having some technical difficulties, so at the end, I want to check back in with you specifically. But just to reiterate what we did today, we started the experiment. So in about, mine is another 15 minutes or something like that, my PCR is going to be done. The PCR is room stable, is temperature stable, so you could just leave it in the room for the next week until you come back to do this with Emily. Best practices says you should put it in the fridge or the freezer. If you need to leave and not come back till tomorrow, it'll be absolutely fine just sitting in the machine until the next day, so don't worry about it. So we made 1 billion copies of a gene, and next time Emily's going to go through and she's going to show you how you can use a restriction enzyme to tell whether these genes that we made are different from each other. And then you'll run a gel to actually visualize that difference, and you'll make a diagnosis on whether it was the space burgers or the space sushi that could have infected the astronauts. Yeah, so with that, we're sort of stopping halfway through, and I just want to open up to questions on what we did and anything with that. And then if anyone is still having any technical issues, I can talk you through through that as well.
I'd like to put $100 down on the sushi 30-1 odds.
That tends to be the popular pick.
Blame it on the sushi always, right?
People always blame it on the bad sushi.
Okay. All right, this is Felicia again.
Yeah.
I did get the app on my phone. So I'm trying to get it to connect by Bluetooth. What I may do is just try tomorrow. I think I do have the app on here though.
Okay.
Set the program up. I got the program.
If you want to give me just 1 second, I'll just check in with everybody else, and then we can just talk through it. So does anyone else have any final questions? No? Awesome. I know it feels like a lot of troubleshooting today. Once you do one of these experiments, once you get the machines running up the first time, it's actually pretty darn easy. So
You have a question?
yes.
I had a question. So once we get to the restriction digest, is that an area where there's a lot of thinking, where the student will have to think a whole lot? I mean, how are they going to, with that restriction, I'm gonna say, how do we make visible their thinking? And what thinking steps, what should we be noticing about their thinking as they're trying to figure out which is the infectious thing by looking at the DNA digest, and what should they be looking for? What should occur to their minds? What should be those guiding questions or prompts, or what should we be looking for? Or what questions should we ask?
Yeah, that's an excellent question. And I will, I'll be sure that Emily addresses it specifically when you're doing the restriction digest, but I can talk to it some now as well. So with the restriction digest, it's all about thinking about how, I mean, really, to me, what I find fascinating about this and what I think is enlightening is that we have these molecular sequences that we know are different, but how do we access them, right? How do we know what is different between two completely microscopic things that are completely clear in a tube, and what tools can we use to investigate those things? So in this case, restriction digests are look for very specific sequences. And so this is one where there isn't something that you can, make a really clear prediction other than the fact that maybe you think it's the sushi or the burger. But sort of thinking really clearly about how you can investigate molecular sequences that you can't see is something that I would put to students to think about. And what are going through the molecular process from making the copies and trying to think about really how these molecules are moving and interacting with each other in real time. One of the things I like to do with this is I don't know if you ever do storyboarding. I love to storyboard biotechnology things because we often, we put it in the machine and it does its magic, but I want a student to draw me, like, what do you think this actually looks like at the molecular level? And so that is actually in one of the lesson plans that we have, is suggesting kids at the PCR to give me a storyboard of the different things. You could do the same thing for a restriction digest, have them thinking about at the molecular level, what would this look like to you, so you can start to conceive of it. That's helpful.
Yeah, that is. Yeah.
Awesome.
Great. Well, with that, I'll say thank you to everybody. And Felicia, I'll stick on with you and make sure that we get you going. Okay. we want to make sure that it works for you. So
Okay.
to everyone else, thank you very
Yeah.
much. I
Thank
hope
you,
this was
Bruce.
useful.
Y'all have a great one, and just let me know if you have questions. Email any of us, group me us.
Buddy.
Oh, sorry. Someone said we did not get, oh, sorry. You answered it. Great. Sorry. I saw the question.
Yeah.
Good.
Now
The
you can
tablet.
see the chat. Yeah.
Yeah, I got it there. Thank you. So Felicia, you got the app on your phone?
Yeah, I did get the app on my phone.
Okay. And can you just hold up the machine that you have to me? Just, I want to make sure you have the right thing. Yep. Perfect. Yeah, that's a Mini 16. That'll work well. Yep. So I'll show you how to connect in the app. Do you have the app open?
Yes, Apple. Uh-huh.
Okay. And is the machine on? Is the blue light flashing in the front of the machine?
Yes, it is.
Awesome. So in the app, you're going to touch, I think it's on the top right. It looks like a little M. I'm doing this from memory, so.
Okay, yeah, I see devices now. Okay.
Yep. And you should see your device and there's a little Bluetooth button and you want to touch the thing that says Bluetooth. And if you do that, the flashing light on the front of the machine should turn a solid blue if it's connected.
And it is. There you go.
Yeah. All right. Perfect.
Yay.
So now you can go back. You can get this started and then you can just leave it. You're in your classroom that you're going to come back to tomorrow.
Yeah.
Yeah. So I would just start it right now and you can come back tomorrow. So now I would go back. I forget what button it is. It's in the top right. You're going to do the new. There's going to be a blue circle with a cross that you're going to press.
Mine is just a plus.
Okay, there we go. Thank you.
Oh, the plus sign? Maybe?
Yep, the plus sign in the top right.
Okay.
Thank you. Yep, hit that. You're going to hit PCR.
All right.
And now you're going to go down and it should have some different temperatures and times.
Right.
So for the initial temperature, you're going to keep it at 94, but you're going to change the time to 30 seconds.
Got that.
The next one is you're going to keep it 94, but you're going to change to 5 seconds. The next one, you're going to change to 57 degrees and also change it to 5 seconds.
Okay.
And then the final one, you're going to keep at 72, but you're going to, or there's two more, sorry. The 72, you're going to keep at 72, but you're going to change it to 5 seconds. And then the last one, it doesn't matter.
Okay, the cycles are 30, okay.
30 cycles, yeah. And I don't know how long that last 72 degrees is, but it really does not affect anything. So you can do that, and now you can just hit save and run, and your machine should go. Just make sure the on button, or it's turned on in the back. Yep. And once you hit save and run, there should be like the green light should turn on in the front too.
Okay, I see it blinking. Green light.
The green light's blinking?
Is that okay?
Yep. As long as your phone should be telling you what's going on as well. So your phone should say heating lid right now, probably.
Yes, very hot. That's it. That's the one.
Awesome. So now you can just leave it. You can bring it doesn't need to stay connected to your phone. Nope.
So, okay.
You can take your phone home. Just leave that right on the bench, leave it plugged in, and it will run.
Okay, I can come back. Thank you so much.
Sure thing. I'm glad we got it working for you.
Awesome. Yay, Felicia.
I know. Look, I've
All
been
right.
showing my little CTAE director all these nice things, because I want him to buy me some of this.
Yeah, if we need to talk to him too, we can help you.
I really want to, yeah, show him. All the cute, cool stuff.
Awesome.
Hey, y'all, thank you so much for staying with me. And
Absolutely. Have a lovely rest of your evening.
okay,
Bye,
you know,
Felicia.
all right, bye-bye.
All
right.
righty. How'd we
Thank
do?
you, Bruce. Awesome.
Good. Excellent. Okay.
Yeah.